Good morning to one and all. I am Parthiban working as assistant professor in the Department of ECE. Now I am going to talk about the subject called electron devices, which is coming under the regulation R 2025. The subject code is EC25C01, which is meant for second year ECE students. Now I am going to talk about the unit 3, which is nothing but the bipolar junction transistors, or it is also called BJT. It is a basic electronic component which is widely used and very famous. So BJTs are the backbone of electronic devices. It can be used as an amplifier or it can be also used as a switch. So BJT as an amplifier is a very popular, particularly as a CE amplifier, that is common emitter amplifier. Basically, BJT consists of three segments, namely the emitter, base and collector. Actually, it is a three-terminal, three-layer device. There are two types of devices that are possible. One is called NPN type, the other one is called PNP. In the NPN, the electrons plays the majority carriers role and holes plays the minority carrier role. The NPN transistor is very popular because the mobility of electrons is more compared with holes. The other type is called PNP, where the majority of carriers are holes and the minority carriers are electrons. So both these forms a pair. So for any amplifier design, we can use either NPN or PNP based on our requirement, based on our design. Generally, we go for the construction of transistors. Transistors are a three-layer semiconductor device. Basically, it will have two N regions and one P region. Then it is called NPN transistor. If it is having a two P layers and one N layer, then it is called PNP transistor. The bipolar refers to the name that current conduction is both by means of electrons as well as by means of holes. So what is the total current produced by a BJT is sum of the majority carriers plus minority carriers, that is electrons plus holes contribution. So for total current induced calculation, we have to include both holes as well as electrons. This is meant for both PNP as well as for NPN transistors. A single PN junction can act as a diode, that we all know. So the PN junction can be biased in two ways. Either it can be forward biased or it can be reverse biased. So in the forward bias, the conduction will be good and it will be the diode will be in on state. There will be a current flow. In the reverse bias, the diode will be in off state and it is called as closed switch, open switch. So these are the two possible combinations. The position of the terminals and the symbol of BJT is depicted in the diagram. You see there are two diodes that can be connected back to back, either if it is a PNP or it is an NPN transistor. The arrow indicates if it is pointing towards the base junction, then it is called PNP type. If it is pointing away from the junction, then it is called NPN type. So in the diagram, you can see the difference between the PNP and NPN. So the base is located in the middle. Actually, the emitter region will be of somewhat bigger. The base will be of minor in nature or less in nature, whereas the collector region is a vast region. So the area occupied by the BJT differs in this way. So the base is the smallest region, whereas the emitter is more or less a large region, whereas the collector is the largest region, we can say. So based on the area of demarcation, we can classify the BJT also. There are, if we go for the transistor currents, the arrow, as I already told you, always indicates the conventional current flow direction. If it is towards the junction, then we can say it is a PNP. If it is away from the junction, then we can say it is an NPN. So the arrow indicates the conventional current flow. For the arrow, naturally for PNP, it indicates the emitter to base direction. Whereas for NPN, you see the current flow direction is from base to emitter. So here the IC is called the collector current, the IB is called the emitter current, and then IC is called the collector current as well as base current as well as emitter current. So what is the total current induced is nothing but the sum of these two currents. By imagining the analogy of transistor, we can say, as I already told you, it is nothing but the two diodes that can be connected back to back, or we can say together. So can be valid for either NPN transistor or for PNP transistor. In the diagram, we can see the analogy for a PNP transistor and for an NPN transistor. So in the PNP transistor, both diodes are towards the junction. Whereas in the NPN transistor, you see both diodes are away from the junction. So this is the way we can have the construction of transistor. Coming on to the biasing of the BJT, generally the nature of biasing will be emitter base will be always forward biased, whereas the base collector will be in reverse bias. Either it can be of PNP type or it can be of NPN type. So the transistor, as I already told you, can operate in two modes, either as an amplifier or it can also act as a switch. So based on the biasing, we can have this. So very important is the emitter base junction. If it is forward biased, then it will act like a forward biased diode. Whereas the base collector junction is a reverse biased, it will act as if like a reverse biased diode. So one will be in on state, the other one will be in off state. So the terminals are very important. The famous three terminals are emitter, base and collector. So the emitter, as I always told you, it is indicated by means of arrow. So the arrow direction will change for PNP as well as for NPN. The collector is the one which is nothing but the generally that is opposite to that of emitter. So it will be always reverse biased in nature. So either it can be a PNP transistor or it can be a NPN transistor. Base is the small middle region that is called base. So why base is kept as a small region? Because the charges or the carrier has to pass through the junction. That is why it is maintained as a very thin layer. As the emitter is heavily doped, the base is lightly doped, whereas the collector is moderately doped. So these are the three doping concentration variation that we can observe. Generally, emitter is heavily doped, means large number of carriers will be there. So the doping level will be quite high. Whereas our base is very thin, which is of very small region, so it is lightly doped. Whereas the collector is a large region where it is averagely or we can say moderately doped. So these are the three dopant variation that we have to infuse for a transistor. So generally the transistor can be worked with a emitter based junction forward bias, whereas the collector based junction forward bias. So there are, as I already told you, the two important applications can lie between the region of operation. Either the transistor can act as an amplifier if it is operated in the active region, or the transistor can act as a switch if it is operated in the cutoff region or saturation region, skipping the active region. So the emitter current is nothing but the sum of base current plus collector current, which is a very important formula for a transistor. I is equal to IB plus IC. So these are the working characteristics of a transistor that we have observed. So the current flow diagram is indicated in the picture, particularly for the NPN as well as for the PNP, along with the notation symbols, along with the representation. This diagram clearly shows the current flow as well as the what is the current induced in each and every element. So these are the references that I used to have for taking the slides. Thanking you one and all for hearing my lecture patiently. Thank you one and all.